Hello, ladies and gentlemen, welcome to Malo Tutorials. In this video, we're going to talk on how to find the variance and the standard deviation from the sample. So here the question is saying find the variance and the standard deviation from this sample, and then we're given the following observations 6, 7, 8, 9, and 10. So firstly, what you have to know is the formula for the variance of the sample. So the variance, which is being denoted by s squared, is equals to the summation of x minus x bar squared over n minus 1, whereby this x is representing each observation or each data point in the data set, and the x bar is the mean, and the n is the total number of the observations which we are having here. So, and then the formula for the standard deviation is equal to the square root of the summation of x minus x bar or squared or over n minus 1. So simply, the standard deviation is equals to the square root of the variance. So therefore, given this information, I'm going to use the formula for drawing a table in order to calculate this variance. So what I'm going to do, I'm going to write the column for x, each data point, and then the column for the mean, and then the column for each data point minus the mean, and then another column for each data point minus the mean, all squared. So now what I'm going to do is to write my data points here as what I said at first, that this x is representing each data point given in the data set. So each data point I'm going to write 6, 7, 8, 9, 10. And then now we need to calculate for the mean. So as I said on the other video, that when you're calculating the mean for ungrouped data, the formula is the summation of each of the data points, of all the data points, or over the total number of the data points. So here my data points, I'm going to say the summation of this one is equals to 6 plus 7 plus 8 plus 9 plus 10. And then the total number of the data points, that's 1, 2, 3, 4, 5. So n is equals to 5. Therefore, the mean is equals to, if we punch this one on the calculator, we're going to find out that the summation is equals to 40 over 5, and the mean is equals to 8. So here I'm going to write my mean 8, 8, 8, 8, 8. And then to fill in this column is saying each data point minus the mean. So I'm going to say each data point minus mean, each data point minus mean, each data point minus mean, and getting the answer for this column. So I'm going to say 6 minus 8, and then I'm going to get negative 2. Then 7 minus 8, that's negative 1. 8 minus 8, that's 0. 9 minus 8, that's 1. Then 10 minus 2, that's equals to 2. And now, for this column is saying each data point minus the mean all squared. So now I'm squaring the answers which I'm having here. So I'm going to say negative 2 squared, that's equals to 4. Negative 1 squared, that's equals to 1. 0 squared, that's 0. 1 squared, 1. Then 2 squared, that's 4. And then finally, I need the summation of x minus x bar all squared. So the summation, that's 4 plus 1, that's 5, plus this one 6 plus 4, 10. Therefore, this means that the summation of x minus x bar all squared is equals to 10. So now the variance, which is being denoted by x squared by s squared, is equals to the summation of x minus x bar all squared all over n. Meaning to say, now we found out that this one is equals to 10. So I'm going to say 10 over, and then n minus 1. My n is 5 minus 1, so I'm going to be left with 4. Therefore, the variance is going to be equals to, if you find this on the calculator, I'm going to find 2.5. So this is the variance. And then for the standard deviation, as I said earlier, that the standard deviation is equal to the square root of the summation of x minus x bar all squared all over n minus 1. And then I've said that if you look, you're going to see that this formula inside here is the formula for the variance. So I'm going to say this is variance, whereby the variance is equals to 2.5. Therefore, the standard deviation going to be equals to 1.58. So let us look in the second question, which is slightly different from this one. Example. So looking on our second example, we're going to see that this question is slightly different from the first example in such a way that now we're having one repeated number 6. So myself, I prefer to add another two columns when I'm having the repeated numbers. So what I'm saying is we're still continuing with our variance and the standard deviation from the sample. So I'm going to add the column. I'm going to write the column for the data points for each data point, and then the column for mean, the column for data point minus the mean, then data points minus the mean all squared, and then I'm going to add another column for frequency, and then the column for frequency multiply by data point minus the mean all squared. So why I'm using this why did I add these two columns? I've added these two columns because I'm having the repeated number here, which is 6. So wherever we are having the repeated numbers from the data set, and then you need to find the variance and the standard deviation, now you add these two columns. Now that's the difference from the first example, where we're not having the repeated numbers. So now let us write our the data points. We are having 13, 3, 6. So on this one we're having repeated. So I'm not going to repeat 6, 6. Why? Because I didn't want to write two main columns here, to have two main rows here. So I'm going to just write 6 only. 1, 6, 17, 9, then 5, 7, and then 4. And then for the mean, how are we going to calculate for the mean? We know that mean is equal to the summation of all data points over n. So our data points here is equals to 13 plus 3 plus 6 times 2 plus 17 plus 9 plus 5 plus 7 plus 4. Therefore, our total value here is 70. And then the total number of the observations, we're going to count our observations here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to find out that we're having n equals to 9. Therefore, our mean is equal to 70 over 9, which is, if you punch on the calculator, we're going to find out that our answer is equal to 7.8. So we're going to write 7.8 here, 7.8, 7.8, 7.8, 7.8, 7.8, 7.8, 7.8. And then after that, now we need to fill for the frequency. So for the frequency, we know that 13 we're having 1, 3 we're having 1, and then 6 we're having 2, then 1, 1, 1, 1, 1. So now we are on this stage now for finding each value in each column, whereby each observation minus the mean. So 13 minus 7.8, that's equal to 5.2. And then 3 minus 7.8, that's negative 4.8. And then 6 minus 7.8, that's negative 1.8. 17 minus 7.8, that's 9.2. And then 9 minus 7.8, that's 1.2. And then 5 minus 7.8, that's negative 2.8. And then 7 minus 7.8, that's equal to negative 0.8. And then 4 minus 7.8, that's equal to negative 3.8. And then after that, now we need to square the answers which we were getting here, because now we are seeing that the column is saying each data point minus the mean all squared. So now we are squaring the values which we are getting here. So we're going to say 5.2 squared, the answer is going to be 27.04, and then negative 4.8 squared, 23.04. So we're going to repeat squaring each value in each column here. So we are going to get 3.24. And then here we're going to get 0.64. And then lastly 14.44. So after this now, here this column is saying we have to multiply the frequency by this deviation. So we're going to say deviation multiplied by the frequency. So we're going to get, since it's 1, we're going to get this one as it is. The same as here again. only here there's going to be difference here. We're going to say 3.24 times 2, so which is going to be 6.48. And then the next is going to become the way it is from this column, since because we are multiplying with 1. 14.44. So now what it means is that we know that the formula for variance is equals to the summation of each data point minus mean all squared over n minus 1. So what it means now is that since we are having the repeated number and then we didn't repeat it, since to avoid too much columns here, so to avoid too much rows here, so what it means is that we are not going to take this one. For this one, we're going to take this portion is going to be covered with this one. So you're going to take the summation of all this of the frequency multiplied by the deviation. So frequency multiplied by the deviation, the total value is 165.56. So we're going to say 165.56 all over our n. Our n is not going to change. We're going to calculate we're going to count the frequency 1, 2. We're going to add the summation of the frequency that's equals to n. 1, 2, that's 4, 5, 6, 7, 8, 9. So the n is equals to 9 minus 1. So we're going to say 8. So we're going to divide by 8. So if we divide by 8, we're going to find out that our variance is equals to 20.695. And then the standard deviation is equal to the square root of our variance. So the standard deviation is equal to our variance is 20.695. Therefore, the standard deviation is equals to 4.55. So let us look on the third example. So our continuation with the example 3. So now what you're going to see is that this third example is also slightly different from the second example in a way that now we're having two main numbers which are repeating itself. So here we're going to see that 5 is repeating itself and then 7 is repeating itself again. Actually, every number here is repeating itself. So, and then the question needs us again to find the variance and the standard deviation. So, what we're going to do is to draw our table as usual, our table of contents. Then here, like this. And we are going to include our frequency and then frequency multiply by the deviation. Deviation squared. So here I'm going to draw my columns here. So here I'm going to write my numbers. So 5, 7, 8, 9, 12. And then I'm going to write the frequency, how many 5s I'm having here. I'm going to see that I'm having 4 5s, and then the 7, I'm having 3, 7, and then the 8, I'm having 2, 8, then the 9, I'm having 1, 8, then the 12, I'm having 2 12s. So after this now, we are going to firstly find our mean. So the summation of observations of n, and then if we add our data points which are having here, we are going to find 90 divided by the total. So the total number, I'm going to add the frequency here. That's 7 plus 3, that's 10, so 12. Therefore, our mean is equals to 7.5. So we're going to write 7.5 here, 7.5 here, 7.5, 7.5, 7.5. Yeah. So after that now, we need to find these values whereby each value is being subtracted by the mean. So we're going to say 5 minus 7.5. So 5 minus 7 is going to be negative 2.5. Then 7 minus 7.5, that's negative 0.5. If you repeat the process here, it's 0.5, 1.5, and then lastly 4.5. Now we are squaring the values which we have got here, the deviations here which you find here. Then now we are squaring them. So if we square here, negative 2.5 squared, we're going to get 6.25. Negative 0.5 squared, that's 0.25 here, 0.25 again. Then 1.5 squared is equals to 2.25 squared, and then if you square here, we're going to get 20.25. And after that, now we need the values here. It means we are going to just multiply the deviation squared multiplied by the frequency. So if the deviation squared multiplied by the frequency, so we're going to say 6.25 times 4 is equals to 25. Then 0.25 times 3, that's 0.75. Then 0.25 times 2, that's 0.5. 2.25 times 1, we're going to get 2.25. 20.25 times 2, that's 40.5. And now we are going to add this frequency multiplied by the deviation squared, and then the total which we are going to get is 69. So after that, now, as we have agreed at first that the deviation is equal to the summation of x minus mean all squared all over n minus 1. So what it means now is I've said that as long as we are having the repeated numbers here, and then we have used this formula which we have used here to calculate, what it means is we are not going to take this one. We say that this one is going to be represented with this column. So it means we are going to take the summation for the frequency multiplied by the deviation squared. And then if you look at it, our summation is 69 over the total number of values. We find out that is 12, then subtract by 1, that's equal to 11. Therefore, we are going to end up with a total of 6.27. And for the standard deviation, we're going to say the square root of the variance. And the variance is 6.27. Therefore, our variance here is going to be 2.504. This is how we solve the variance and the standard deviation of samples. The same as with the population, this is the same way which we solve even if the question is like this. It's only that our formulas are the ones which are differs, but the way we are solving is the same way which we do when we are solving for the population. So thanks for watching, guys. Don't forget to subscribe, like, and share.